Okay, we are live. Sorry, I was updating a piece of software right before we went live because I like to live dangerously. Alright, so we are currently live and we are going to be working on Transformers Lessons 3, Transformers Level 1, Lessons 3 and 4, and that is Transformer Connections and Real World Transformer Connections. Uh, Transformer Connections is going to focus on schematics and stuff. And then Real World Transformer Connections is going to have a bunch of pictures of Transformers up on poles that you'll see some pictures here. Let's see. Here's a good picture of the inside of it's a regular transformer that we would be hooking up, a three-phase transformer. You have your looks like your high leg coming in, or not your high leg, your high voltage side coming in right here with the smaller wires, and then your low voltage side, relatively low voltage side, going out on the larger wires. They're not all that much larger if you look at them, but you can see that they are parallel. Then here is some schematic versions of three-phase transformers. Here's some, these look like single-phase transformers that are wired, or no. Oh, this is open delta. Okay, yeah, I see it now. Alright, all that being said, let's get back to the Socrative. I hope everybody has gone and picked up their test at this point, because it's almost time for them to go pick up, like go clear out the test. So, if you have not gone and picked up your test, you need to contact the school and let them know, hey, I'm gonna be there. I'm just running behind or something. I don't know exactly the system they have in place, but you do need to get in contact with them. All right. The majority of three-phase transmission circuits in the United States are designed with only three-phase transformers connected together to obtain three-phase power. That is false because it is single-phase. So if you look back here, these are three single-phase transformers connected together to get three-phase. We will talk about exactly how they're connected together in a little bit, but there are three single-phase transformers connected to give you three-phase. Today, the majority of dwellings are wired with three-wire service. That is true. Most houses have a three-wire connection. That's two hots and a neutral coming from the transformer. The secondary winding of a single-phase transformer, the neutral wire generally carries a current equal to that of either of the two outside wires. So the neutral wire will carry the difference of the two outside wires. So this one will be false. Let's see. The transformer polarity, it refers to the voltage vector relationship. This is how we talked about voltages being in phase or out of phase before, whenever we were talking about AC theory. and that is carrying into transformers. Transformer, and all you need, all you will need to know about this is that this is the definition of transformer polarity. But to get a more thorough understanding, it has to do with the different voltage legs and how they are in phase with each other or out of phase with each other. Methods used to test polarity in the book. I want to say it's on page 74. There it is. It lists the three that are incorrect because those are three different ways to test for transformer polarity. And then this last one doesn't exist. It's not a thing. You can't find it in the book. A blank is a three-phase connection method that has the wire from the ends of each coil connected end to end to form a closed loop. That is a delta connection. I hope I didn't get into poison ivy. In a balanced three-phase delta connected system, the line current is equal to delta connection. So let me draw some things. Let's right click, see if I can blank drawing. There we go. I prepared something. Alright. So you have these. So each one of these is a single phase transformer. You have the primary coils on top and the secondary coils on bottom. A delta transformer, and I'm going to use red just so it pops out a little bit better. You'll have A connected to B, and then B connected to C, and then C comes up here and connects all the way back to A. And then you have connections made to each of the lines. Now let's pop over here and like bubble in all the connections. Oh, that's not the right size. If there's not a bubble, it didn't make a connection. Alright, so we have all of our connections made. So you can see current will go through one coil to the next coil to the next coil and then back to the beginning. That is a delta connection. I do have a video on my YouTube channel that details this a lot more thoroughly, and I spent like 20 minutes going over. I don't know exactly how long. Don't find the video based on the time I just said. I spent time detailing each one of these just so that it'd be easier. So up here, if I drew this out in a different form, man, it was starting to look good right here, and then it just went to shit. Okay, so you have A and A. Oh man, B and C. You have B and C. So A is connected to B, B is connected to C, C is connected back to A. And that's what I drew over here. The other form of transformer wiring is a Y connection, and I will draw that in the secondary side. So you have A, B, and C, and A, B, C. You can see that one side of all of these is connected to all of the others. See if I can make it connect. Yeah. And then you have A connected there, B connected there, and C connected there. So you can see a drastic difference between the drawings of the two. Yes, this top one was delta. Oh, that's a... In the Greek alphabet, delta is triangle. So delta is the word for triangle. Then down here is Y. So these are the two drawings, and you can see the main difference is what happens to the second connection on each coil. If the second connection on the coil goes to another coil, then it is goes to just one other coil, then it's a delta. If one side of all three coils connects together or goes to the same connection, then it's a Y. All right. In a balanced three-phase delta connected system, the line current is equal to blank times the current in one of the coils. That is, in all three-phase system, it's 1.73. Something's going to be times 1.73. A good way to remember that is a Y transformer is going to be like 120,208 or 277,480. So you can see that the bottom number is not half of the upper number, or the upper number isn't twice the bottom number, however you want to say it. And down here, again, it's not double. Where here, your transformer, a delta transformer is going to be like 120, 240. Or, you're not going to have a 240, 480. But that is another option. If you had this would be a possible transformer with delta, but it's not something you're ever going to see. So a delta has normal voltages, what I would consider, and a Y transformer has weird voltages. Why is it weird? Why is it weird? Okay, and that's an easy way to remember that. And if you ever asked, current is equal, so in a delta, its current is equal to 1.73. In Y, its voltage is equal to 1.73, the voltage of one of the coils. A blank connection, a Y connection. Okay, and we just covered Y connections. A Y system is also known as a star system. I think that's just a piece of trivia that they want you to know. I've never heard it called a star system, but you might find an instance where it is. A Y to delta connection may be made with 3 single-phase transformers. Yes. If you look in your book, Did I put a page? Yeah, on page 84 they have a Y to delta connection drawn out for you. What I drew for you here is a delta to Y, but a Y to delta would just be the same flipped. Yeah. A primary Y won't have a neutral connection, but a secondary Y will have a neutral connection. You cannot have there isn't a way to get a neutral connection on a delta without splitting this bottom coil, splitting one of the coils, and making what they call a center tap delta. But with a Y, it just naturally forms a neutral, and you can do that. That's why we have so much 277 volt lighting or 120/208, because if you have a three-phase system, the easiest way to get a neutral is with a Y. But if you need a neutral, like with a Y, you can't have normal voltage. You can't have 240 volts with a neutral, with a Y system. If you need 240 volts, say you have some sort of three-phase system that needs 120/240 to be possible, then you're going to have to go with a center tapped delta, which that means if you read from here to here, you're going to have a high leg because you're going through 1.5 coils, versus if you read from here to here, you would get 120. If you read across that coil, you'd get 120. If you read across C, you'd get 120. But if you read from, oh wait, no, these would be 240 volt coils. My bad. 240, 240, and 240. So if you read from here to here, it's 240. If you read from here to here, it's 240. If you read from here to the ground, or neutral, you'd get 120. And same if you read from here to the ground. But if you read all the way here, you're going to go through a 240 volt coil and a 120 volt coil, and you will not get anything useful. So they skip, if they're using 120 volt or single phase loads, they'll have like breaker, breaker, skip, breaker, breaker, skip, because they'll have 120, 120, nut, and they'll be like 190, and then 120, 120, and 190. And that's not, 190 is not a useful voltage for anything. So they skip that breaker. Or they could use a 2-pole breaker and get 240. A lot of them will strategically place the 2-pole breakers in the panel so that you get 240 in different spots. Alright. In a Y to delta connection of 3 single-phase transformers, one unit may be disconnected from the circuit. Okay, so in this instance, this would be you disconnecting one transformer, or like clearing it out, getting rid of one of the transformers. And then you have what they call an open delta. And the open delta still can do all the things a regular transformer can do, just at 57% of its capacity. But it lets you keep the building running while you do repairs on one of the transformers. This is more of a lineman thing. We're not going to be doing this as inside electricians, but linemen will shut down part of a building, or lose a phase, like shut down one of the transformers, pull it, put a new one up, and as long as the building is not running at maximum capacity, it'll you won't the end user won't notice much of a difference. A three-phase bank of single-phase transformers connected delta delta. Yeah. A blank connection may also be called a V connection because only two sides of the delta triangle are included. Open delta. So we have 3 or 4 questions about open deltas. So yes, all 3 phases will have the same relative polarity to each other. And you can see all those relative polarities in, I think, about page 93, 94. Actually, this one is on page 94. So around there in your book, you'll see a lot of those. Okay, I'm only a little bit over on time. So I'm going to start the new quiz. I've noticed that a lot of people come in at the at the very beginning of me putting out a quiz. Like, I got on at 2 o'clock and there wasn't a new quiz. I'm like, well, shit, give me a minute. Alright. I will see you guys at, what, 3:45. I'll see you guys at 3:45. Yeah. I'm ending the stream here. You have a good couple hours.